Some of the most dangerous flaws in the world are the ones you can't see. A hidden crack inside an airplane wing, a pipeline, a bridge. So how do we find them without breaking them apart? This is NDT, non-destructive testing, a way to inspect the quality, condition, and integrity of materials and structures without causing any damage. The part you test stays usable. You'll also hear it called NDE or NDI. Same idea. Old-school destructive testing breaks the sample to learn its limits. NDT does the opposite. It checks the part while keeping it whole. That means safer equipment, longer lifespan, and catching problems before they become failures. It reveals the hidden enemies: cracks, corrosion, voids, porosity, weld failures, and metal thinning, using sound, radiation, magnetism, heat, and liquids. Visual testing, the simplest and most used method. Just the eye, but only surface deep. Ultrasonic testing sends sound waves inside to find what's buried deep. Radiographic testing uses X-rays or gamma rays, like an X-ray for metal welds. Magnetic particle testing reveals surface cracks on iron and steel. Dye penetrant seeps into tiny surface cracks and makes them visible. Eddy current uses electromagnetism, fast and no contact needed. Now, those 6 are the conventional NDT methods, but add advanced equipment and attachments, and they level up. Techniques like phased array and TOFD scan faster and deeper, mapping flaws in stunning detail. And the next leap, robotics and automation, inspecting where humans can't safely reach. From aerospace and oil and gas to power, manufacturing, transport, and construction, NDT keeps the world's critical machines running safely. It started in the 1800s, inspecting train axles. Then X-rays in 1895 changed everything. Today, NDT goes fully digital. NDT, seeing the unseen, before it's too late. If this made it click, subscribe for more.